In Chapter 6, we are going to conduct output analysis for terminating simulations. In this chapter, we will first discuss how to collect output, calculate confidence interval, and determine how many replications are needed to get desired confidence interval. We also then try to compare two scenarios using Arena Output Analyzer. We will compare many scenarios via Arena Process Analyzer. We will also introduce Ch6, a simulation optimization tool. Terminating simulation and a steady-state simulation are different. Terminating means well-defined finite run length. Steady-state means theoretically infinite run, which practically is a very long run. In this chapter, we will analyze terminating simulation outputs. The replication parameters setting should check both statistics and systems for initialize between replications. We will continue to use Model 5-3 as our example. The model is renamed as Model 6-1. We try to run it for 10 replications and obtain 10 results. After we are sure the simulation is correct, we should try to collect data for output analysis. To allow faster simulation, we can use batch run without animation. The date in a simulation run is not IID. We must run simulation multiple times to get statistically independent results for output analysis. While it is possible to single out results one by one from the crystal reports, it is better to use some methods to collect our desired statistical results directly into a .dat file. In this case, .dat file is a binary file that cannot be edited by Notepad. The .dat file can be analyzed by the Arena Output Analyzer. Let's see what Arena functions are available for data collection. In these functions, D means dstat, T means tally, N means number, AVG is average, C is counter. We have seen other functions before, such as NR and MR. We introduced how to calculate confidence intervals in Chapter 2. This is the mean, standard deviation, and confidence interval halfways calculated with formulas. If you run 10 replications yourself, your result may be slightly different. This is the method used in calculating confidence interval, or halfways. In order to reduce halfways, we must increase the number of replication number, n. The question is, what should be the value of n? The value of t distribution depends on n, so it will be a hard question to solve. We may replace t with z, normal distribution. Then we can get approximation formulas to calculate n. We will use the formulas in this slide to calculate the number of replications needed to get the desired halved width. We will illustrate how to use the formulas in the next slide. Going back to Model 6-1, with the first 10 replications, we get the 95% halfways as A13. We wanted to go down to 250 by using the formulas from the previous slide. We got 80 or 106. We can be a bit generous and set n to be 110. We save this model as Model 6-2 and rerun it with 110 replications. As a result, halfways goes down to 370. We may use the formulas again to set n to an even larger value in order to reduce the halfways to 250. In Model 6-3, it runs 1000 replications. You may run it after class to see what you get. It is important to emphasize that confidence interval is the interval that the target expected value will fall into 95% probability. It does not mean that the interval will contain 95% of data collected. We start with comparison of two scenarios. Model 6-4 runs 110 replications. In order to use Arena Output Analyzer, we need to modify the statistics modules to output total cost and % rejected to our .dat file. The files will be saved automatically to the same folder as Arena model. We have two scenarios, base case and more resources case, similar to what we discussed in Model 5-3. Remember, we need to rename the .dat files to another name after each case. Otherwise, the files will be overreturned each time the simulation runs. The crystal reports provide the confidence intervals for the two cases. There are no overlap, so it seems that the more resources case is more expensive. We would like to double-check this conclusion with Arena Output Analyzer. As we explained, we need to save the statistics to our .dat files in order to analyze them in Output Analyzer. Start Output Analyzer. Click the New button to create a new data group. In the Output 1 interface, click Add to add total cost, base case.dat, total cost, more resources.dat, % rejected, base case.dat, and % rejected, more resources.dat to the data group. These four files are provided in the book examples folder. They are the results of the two scenarios. We are going to compare means first. Go through these steps and click OK in the Compare Means dialog. The plot is shown in the next slide. This is the compare means plot. We confirm that there is a statistically significant difference on both output performance measures.